Hi, thanks for coming in the morning here. I know it's quite early, and I also had to get out of bed. But anyway, that's who I am now. So when we think about debugging, well, I want to show you here the first bug. Interestingly, it wasn't really a bug. It was a moth for the pedantics here. It was a moth that flew in like in the 1940s into a computer and shorted the relays and make zip. The moth was dead, but also a computer program, which wasn't that great. That was the first instance of a bug found. But to quote Edgar Dijkstra, if debugging is the process of removing software bugs, then programming must be the process of putting them in. And as we're all doing quite a lot of program here, we probably also do quite a lot of debugging here. So let's start with demo application. Consider you have a quite anxious boss and he tells you you have to write this many lines of code per day because he grew up in like the 70s and that's how they did it there back then. And so you write a small program called counter.py and it has to count lines of code, but you have a bug in there. It returns 0, and of course this program at least prints, so it should have at least one line of code. So that's a problem. So what we expect is it returns something like 26. So let's look shortly at the code, but not too long because it's a talk about debugger. So probably when you glance on it, you might not have an idea, but debuggers are your friend. Yeah, and I'm also working sometimes on Java debugging, on other things, but I also looked into debugging for Python just because it's quite interesting and it's interesting to see how it contrasts with Java debugging. So then you might wonder, in the talk I showed you that we need a monitoring API. So, but why do we need such an API? And now let's join me down the rabbit hole. The thing is, Java has built-in support for debugging features, so it has a built-in protocol, it has this since the 90s. But Python? Nah. Python doesn't have any idea about, but Python, so any one of you who thinks that an interpreter like your CPython has an idea, knows what a breakpoint is? Hands up, who thinks that Python has an idea? Okay, who thinks that Python is oblivious of anything called a breakpoint? Yeah, it was a trick question, of course, no. So that's a problem. And so how do we deal with it? Any ideas? How can we implement a pretty basic debugger? Consider we can modify code and such. We have control over the project. Any ideas? Could we? Yes. Now we can. Let's take the code here. That's the code from before. I've just wrapped these if statements in a method, so we don't have to make the if statements all the time, write it down all the time. So we prefix every line with a debugging statement. So that's possible. We have semicolons for this purpose in Python, I believe, for this exact purpose, and you can do this. But that works kind of fine. And how the debugging works, as you probably might have suggested already, we just check, where is there a breakpoint at this current file and this current line? We're only considering line breakpoints here. Then if so, just open the debugging shell. For the shell, we can use something like bpython shell to make our life easier, but that's a pretty decent, simple debugger. The only problem here is, where do we get the file on the line from? We can't use __ line because that would be the current line. That would be kind of pointless because we know that we're in a debugging function. So what can we do? There's sys.getFrame for to save us. Anyone has an idea why this method, unlike many other methods, has an underscore? Yeah, the answer was maybe because it's interpreter specific, and that's totally true. It's kind of interpreter specific, but it also exists in other interpreters. So it's there because it's kind of a CPython implementation detail, and that's what like CPython does. It puts an underscore on it. The only main problem is this is a central method for like debugging, and we need it for even the simplest debugger. So if PyPy, for example, would decide like, oh, we don't implement it because it's implementation specific, then all people would be like, now how do we debug? So the CPython, the PyPy people decided we still want to kind of have these because PyPy is fast, but debugging PyPy would be nice. So when you look up their documentation, they explicitly write locus global sys.getFrame and sys.xinfo and sys.ztrace, which we come to later, work in PyPy, but they incur performance penalty that can be huge by disabling the just-in-time compiler over the enclosing just-in-time scope. And that's typically a problem when you're doing these like low-level stuffs. You're not being fast, but if we're honest, when we're doing debugging, it's not that trained of a problem if we're slightly slower. And even runtimes like the OpenJDK, they disable the just-in-time compiler when you're debugging a certain method. So how does this work now with DBG? Is consider here we have like our main method that calls count code lines, that counts is code line, and then on top has the dbg method. What this.getFrame 0 gives us in dbg is like the current frame, but that's pointless because we already know that we're in the debugging function. This.getFrame 1, that gives us the method that we're after to. So we now know the current, so we get some information. And yeah, what do we get? It's pretty basic. We get a line number, that's good. We get a global, so everything you can access from the global variables. We get the locals, so you can access the local dictionary of variables. And you can also get a line, the file name. And that's pretty cool because that's all we essentially need for a debugger, because we can access the locals, the globals, we know where we are, and that's really, really nice. We can use this to implement DBG, and that's pretty simple. We just get a frame below the DBG frame. We then get the line number, we get the file name, and the file name is actually attached to like the code object. So we also can get a code object, which is pretty interesting because we can kind of modify things like the docs command, and even when we're pretty nasty, modify the code itself, at least in CPython. Please don't do this, but you can have quite a lot of fun with writing debuggers. And then we get a file on the line. For simplicity here, just take the file stem to make it easier in the demos, and then when we're at a breakpoint, we go into the shell, and that's fine. And that's essentially a debugger. We just wrote a debugger in 6 lines of code, and yeah, I could go home with a nice croissant, but that's probably not all in my talk. We probably want to automate this, because if I'm honest, we don't want to write DBG in front of every line that we might potentially debug. I have to tell you, there are 2 ways. There are the ways in the olden days, in the dark ages, that we don't do anymore, except if we are the official Python command line debugger, but there are the pre-3.12 ways, and cover your eyes, it's horrible. And then there are the nice ways introduced with Python 3.12. I have to say I have nothing to do with the change between that occurred in Python 3.12. I just found it, find it great, and wanted to tell people here because nobody's doing it. So anyway, in the pre-3.12 ways, I was kind of sad because I told you before that sys.ztrace is not great. When you use it, PyPy is like, yes, we know what you're doing, please don't, and we de-optimize your code. So what sys.ztrace is, it's a pretty simple method. You give it a handler, and and I hope some of you are familiar with like the Python type syntax, but essentially the handler gets a frame, which we saw before, which contains like the line number, the file, and everything, and it gets an event, which is essentially the event type. It could be like call, line, return, and something. So what event appeared, and an argument. For example, for line, it could contain the line number. What do we do now? What does it do now? So when we set trace and we set a handler in there, every time a function is called, for example here the count lines, the handler is called with a call event. That's pretty decent. So we get notified whenever a method is called, and also above, and we don't have any more information here. We just get a call event, and that's fine. But the cool thing is, the signature that I showed you before is not totally true. So it can return. So it can either return none, which is like, oh yeah, please don't do anything in the method's body, but it can also return a callable. So the idea is that it returns in turn a handler that's then called on things like line and return. And the line things can return another handler, and that is for the opcodes. But we're not covering this here. We're only looking into line breakpoints. So that's pretty decent. And we can use this. We can have an inner handler called for every line. And now consider back to our DBG example. So when we have an inner handler that's called at every line, we have essentially a way to automate our DBG placing and front stuff, which is really, really decent. So what we can do, we change the method name sneakily to inner handler, and we just check the event. If the event is not line, we just ignore it. And that's pretty decent. That's a simple debugger. And we just set a set trace handler, and that's pretty nice. So how do we then, if you have breakpoints, enable things like single stepping? That's not difficult, because if you consider, we can just extend that breakpoint. We can just check at every breakpoint, hey, a condition. And when we single step, we just check that that we're not stepping in, so that the next line, here's step out. For step out, we're just checking that we're at the top frame. For single stepping, we're checking that only the line number changed. And for step in, we're just taking the next thing that comes in, which is pretty simple. So this way, with a few lines of more code, we can have a simple Python debugger, and it works good enough. We can even use it to debug our own programs. The question is now, do we get line events for every function and every line? Any ideas here? Any opinions? Do we need to get line events for every function of every line that we might want to debug in the program? Anyone? Any opinion? Yes, that's cool. Yes, of course. And that's a problem. What? And you guessed right, because it was a 50-50 chance. Yay! The audience wakes up. Woohoo! It's only 9:50. It's only 10. So woo. So yeah, and that's a problem. So if we see here, why is this the case? Because consider we have here the handler, and we're like, yeah, we don't return anything because the user hasn't set a breakpoint. We assume now that the user set a breakpoint is colon, and that's fine. It calls it here. The only problem is our user is sneaky, and the user decides just in time in his count line when he's in the handler, hey, by the way, I want to add a breakpoint to count lines. Yes, that's sneaky, but the user can do this, because why not? That's a normal behavior when we debug, that we set breakpoints at other methods. And that's pretty problematic, because when you see here, the handler already returned none for the count lines. So we never get line breakpoints for this invocation of count lines. So that's a problem. And therefore, we have to return a line handler for every function that a user might possibly set a breakpoint in. So probably not all the internal functions, but some users might want to set a breakpoint there, so they might get disappointed when it doesn't work. So this is slow. So that's not great. And it was slow for like the last 20 years. Nobody cared, but then somebody cared and thought, what should we do? We add a new API. And as I said before, that's not my doing. That's what someone else did, but they did a really great job, and they got it in like last October, and I'm really grateful for them. It's the PP669. It's a really nice read. So if you want to read the document on how this works under the hood, it's it has everything. It has examples, it had method description and everything. I put a QR code there. So the Python enhancement proposal is called Low Impact Monitoring for CPython, and it was done by Mark Shannon. He started it like in 2021, and it took some time till it got properly accepted, but it's in now, and people like it, so that's cool. So how does it work? The idea is we add a new API, and with this API, people thought again like, what are the pain points in debugging? What are the pain points in implementing debuggers? And they wrote an API specifically for the use case of debugging and profiling. So essentially, at the beginning, we're doing some aliases. There's everything lives in the sys.monitoring namespace, so we just get an alias mon. Every event lives in e, so in mon.events. And we have different tool IDs because we can have multiple tools simultaneously running. For example, we have an ID for profilers, we have an ID for coverage tools, and that's pretty cool. So in the beginning, we register our tool. We have a debugger, we use the debug ID and give it a name. Giving names to things is really a good thing when you want to debug your debugger and you might want to do it in time. And yes, this breaks your head, but I've done it before. It's doable, especially when you're debugging your debugging while debugging your debugger. Anyway, then what you have to do, we need to have some way to get notified about about lines being invoked. So we register some callbacks. Let's register a callback called for e.line, and we call it the line handler, and for every time a Python method is started, call it the start handler. And so the start handler looks quite simple. It gets the code object, and it gets some offset, byte offset in the file, and then we get the line handler, and it gets parsed also the code object and the line. And the cool thing is we can return from the line handler a disable, and this means that this line is the thing is disabled until someone calls restart event, and it's pretty cool because we can now implement quite nice coverage tools because this line event will only be hit once. Pretty cool for line coverage in my opinion. So that's cool. So we registered some callbacks, but if we only register them, nothing changes. So what we then do, we have to set some events, and how we can do it, we can set events either globally, like for all methods, or locally. And here in this, what we need is we need to be notified whenever method, whenever method is entered. And then later, when we know, oh, please, the user set a breakpoint in a function, we can set the line events for this specific function. So that's very cool. Another note here, it's emitted per thread and not per interpreter, and that's pretty big because Python is getting more and more in the way of multi-threading. And to quote Lukas Langer, the biggest opportunity of the PEP isn't even the speed, it's the fact that a debugger built on top of it will automatically support all threads and have some threading support, and it's pretty cool because this wasn't possible with sys.set trace. And that's especially related to the changes that came in with Python 3.13 with making the global interpreter lock optional in CPython. So I said before we have the globally and locally set events. So essentially we enable the enabled events per function are the combination. And the cool thing here, the power is besides like the threading support, it's in the fine-grained configuration because we're only getting the line events for the functions that we really care about. And it's even cooler, even if you're in the method f, you can set the events in f for the function f, which is pretty cool. So consider this short example. We have our line handler that registered, and now we have a function f. It's called, and then we print hello, and then we enable the line events for the method while we're in. Then we print inner, and then we disable the line events. And so what's output is that exactly for the lines that we would expect, for the two lines, it's the line handler is called and prints something, and that's pretty cool because this alleviates the need for having a line handler for every line. We just set a line handler for lines in the functions that we really need, and that speeds up so much. But now you might wonder, there's so many API functions, what's fast, what can we do easily? And according, this is also from the PEP, the things that are pretty slow, so for example, set global events, because how this all works is that the Python interpreter takes the bytecode and modifies it for every function. Essentially replace, for example, the first bytecode for every line in your Python program, in your compiled Python program, with like a Python operation that says, oh, by the way, call this line handler. Then use tool ID is also quite expensive because it has to do some logs. Local events is rather fast. You can do it often, but don't do it too often. And register callbacks and get tool is pretty fast. And that's cool because get tool is used internally a lot to say, oh, get me this tool for this name. And the important thing is we want to do the slow things as early as possible because then the performance impact is not as large. And that's pretty important. And so, but we usually do this as early as possible, as shown before. So back to a debugger. How do we do this now? So in the start handler, it's pretty simple. We have a method that essentially just checks, oh, do we have any breakpoint in this method currently? If yes, we enable the line events. If no, we don't. And that's simple. And if we later then enable the breakpoint in the line handler, then we enable the breakpoints just for this method too. So here we're in the line handler, and it looks the same as before. We check at the breakpoint, are we at this breakpoint in this line, and it's fine, and we restart the shell. And you see here, we still have to use the sys.getFrame here. That's a pity, but they didn't include like an API for this. But it's still there, so we can use it. There are quite a lot of events here. There are events for almost everything. For start, for resume, for return, there's even, and that's cool, you might know that when you stopped iterator previously, there was an exception thrown, but there were also changes that there isn't really an exception thrown, so this has some performance here. So that's the reason why we have explicitly a PyYield we haven't stop iteration event, but it's cool. We get lots more information than before. And now you might also wonder what's the performance, and so I thought this too, and I just hacked PyPerformance to do some trials. That's PyPerformance is a really nice benchmarking suite for Python. And so what essentially they compared the sys.ztrace handler that doesn't do anything, that has no breakpoint, with the monitoring API that does have no breakpoint, but the monitoring API just sets the PyStart events. And for good measure, I also compared the monitoring API when we set for every line breakpoint. So it's closer to what sys.ztrace do, but usually we don't enable the line breakpoints for almost any function, just the functions that we will say breakpoint in, which are usually a minimal amount. So yeah, I took this benchmarking suite, and the cool thing is, it's faster. So this is compared to the runtime of the program without attaching debugger. And the sys.ztrace approach is 3.5 times slower, which is a pity. It's pretty slow. And then with the monitoring API, the basic one is just 20%. It's just 20% slower, which is nice. And even when we're enabling all line breakpoint, all line events, it's still faster, so it's substantial. So we're essentially going in reality from like 3.5 times the runtime to only 20% slower, which is pretty nice. And we kind of a breakdown for all methods. And you see here, some of the bars are so high that I can't plot it here because my things end at 10 times slower. And that's pretty cool. So is it used? You might wonder. Kind of yes and kind of no. So it's not yet in PDB. The interesting thing is I gave this presentation in April, and I thought surely this morning they must have implemented in the official command line debugger of Python. No, they didn't. it's not yet in there. And there are problems, and to quote Tin Zhao, who wrote a pull request to adding this, after this change, we will have the chance to build a much faster debugger for breakpoints. We do not need to trigger a trace function all the time and line checking for line number. The bad news is it's almost impossible to do a completely backward compatible transition because the mechanism is quite different, so we will probably never see a PDB version with this in. But you can go to other vendors, like for example the debuggers for VS Code or for PyCharm. They included it already, so you can use it there. That makes PDB quite slow. You can implement your own debuggers with ease. If you want to find out more about the blog series on there, where I also debug the proper, where also developed the proper debugger with both set trace and sys.monitoring. You find myself on Twitter and on Mastodon as Program Nerd, and the blog every 2 weeks about the topic on debugging, profiling, and eBPF. And my team, where I work at, it's a submachine. We are a pretty nice team. We have nice t-shirts and everything, but we do like an OpenJK distribution. They're the third biggest contributor in this open source project. You can find them at submachine.io. And that was my talk. Thanks for all coming here early in the morning. I hope you liked it.
So thank you, Johannes, for your talk. Thank you for everything. Has anyone questions? Yes.
Thank you very much. So about something was very interesting to me. You said that it modifies the bytecode.
Yes.
It goes down to the bytecode level, and so if you register an event globally, it's going to modify all the functions?
Yes, and if so, what I hopefully it works. So if we take here the bytecode for our function, here it's print hello, as we've seen before, and what it does, it knows, okay, here's the line that starts, and so what it does, and I looked up in CPython internally, so what it does, it modifies this line and replaces the load const with a bytecode instruction that says, oh, by the way, call a handler for this line, call a handler for like the debugger, and then afterwards use the load const bytecode. So that's the cool thing with this set trace that was internally in CPython. They had ifs and else and whatever in there, but with this it's fast because we're modifying the bytecode. And when you set events globally, you're modifying the bytecode of all methods, and that's pretty darn slow, especially if you load a lot. So, but if you do it locally, you see here that method, a small method that doesn't have that many bytecodes in there, so that's fine. Yeah.
So I guess, sorry, the question, that was the preliminary to the question. My question actually is, if you register an event and then remove it, do you modify twice the bytecode?
If you register and then remove it, that's fine. But it's only when you set the events that you modify. When you set the events and you remove the events, then you're also modifying bytecode, of course, yes. Every time you change the events, you're modifying bytecode, but that's usually fine with methods. Globally, don't remove and add all the time. That's not a good idea. Add them at the beginning.
Okay, thank you.
And the cool thing is it's done at load time. So every time a new program is loaded, it's just done. So it's pretty darn fast.
Has anyone any other questions? So yeah, I have a small one. So I saw that you started playing with ePBF, right?
Yeah.
Do you think it can be used for CPython or?
So there are people doing monitoring for eBPF in CPython, doing monitoring with eBPF for CPython. It might be used. Many people try to use it because CPython is pretty nice because it doesn't have a just-in-time compiler, so it's easy to write a stack. And there are many tools that do this, but for debugging, you can't use ePF. I think there was a question in the front.
This will be the last one.
Maybe it's not 100% related, but I know this is very useful to debug locally, right, when you have the code. And I know we use best practices all the time, right? We write our unit tests and so on and so forth, and we try our best. But sometimes the errors that you want to trace is in a distributed environment, you know? Is there anything already that uses this kind of method in a distributed environment that can spawn a debugger?
Maybe there is, but I sadly don't know. Oh, sorry. If someone of you know, I don't know because I'm using Python to debug to help implement small scripts for my OpenJK development, developing Java with Python.
Okay, so thank you, Johannes. Can we have another round of applause?